Okay, remember in class that you did the elements versus compounds sort to review the information that you learned in sixth grade, the difference between an element and a compound. Okay, we're going to take it a little bit further and we are going to talk about the smallest unit of matter, which is the atom. Okay, atoms are basically just small pieces of an element. Elements are our purest substance. We find them on the periodic table, okay? And atoms are just pieces of that element. So before we get started, you need to draw yourself a model of an atom. Now, mine is a little messed up. We shouldn't have one of these orbitals going through the nucleus, okay? And I'll explain that a little bit more in just a second. So go ahead and draw yourself a quick pause if you need to. All right, basic atomic structure. We will be going back and forth from the notes to the model. After we learn a specific part of the atom, we will label it on our model. Now, let's talk a little bit, go back to the model. This is a very basic version of the model of the atom that we use today. We will talk more in depth as we go on about the different models that we've had over the years, why we've changed them, what discoveries we've made, and what are some limitations or what are some things that are not right about the models compared to the actual atom. So again, we start with element. Element is a matter composed of one type of element, or atom, excuse me. And remember again, we find all of our elements on our periodic table of elements that we have in our journal. Okay. An atom is the smallest piece of matter that still has the properties of the element. Okay, so for instance, the element oxygen that we all know and are familiar with. Okay, there are millions of atoms of oxygen. Okay, they will still hold the same properties as the element of oxygen. They're still going to be a gas, okay, by themselves unless they bond with another element to make a different type of molecule. But by themselves, they'll still be gas, just like the elements. Okay, all of our matter is made up of atoms. So everything that is a piece of matter is made up of atoms, and atoms are completely tiny, 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 tiny. We talked about this in class. Remember the example of your pencil point and how many atoms are on your pencil point. Okay, now to get to the basic structure of the atom. Okay, the first part of an atom is called, one of the subatomic particles is called a proton. It holds a positive charge, and it has a mass of about 1 AMU, and AMU stands for atomic mass unit. Okay, so if we go back over to our model, okay, in our model, we can see that our positive, our particles that are marked with a plus sign to represent the positive charge are going to be our protons. So go ahead and label those. Okay, and as you can see, they're all here in the center of the atom, which we call the nucleus, and we'll talk more about that in just a second. And you can see, if you count up, 1, 2, 3, 4, we have 4 protons. Okay. The next particle is the neutron. The neutron is just like it sounds. It's either neutral or no charge. You can interchange those. Just so you know that a neutron has absolutely no charge, and that's why we use a zero or what looks just like an empty circle to denote where a neutron is. Okay? And this is not correct. Let's change this. A neutron is approximately about a 1 AMU as well, 1 atomic mass unit. So our protons and our neutrons are almost the same size. They're a little bit different as far as mass goes, but they're almost the same size. So we need to make that change right here. They're approximately 1 AMU as well. And if we look over here, again, the same location, the nucleus, okay? We have these empty circles, which are our neutrons. And those empty circles stand for the no charge. And again, if you count them up, you can see that we have 1, 2, 3, 4, 5 neutrons. And then our last particle is an electron. And we need to change this part here. Okay? Electron has a negative charge, but it is significantly less than 1. It's very close to 0, actually, in amount of mass. Electrons are super, super tiny compared to our protons and our electrons. Okay, they do not have a lot of mass at all. Okay, so actually, and I think I need to change that. Okay, and let's just go ahead, since I wrote it, we'll just put less than, so we know what I was trying to say. Okay, again, very, 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 very tiny. Okay, and our electrons are out here in what we call the electron cloud. Okay, these electron orbitals, these rings that you see, okay, in today's modern model, we call it a cloud of electrons. Okay, these electrons have different amounts of energy and they're moving around the atom in different locations within the electron cloud. So let's label this an electron. And again, you can see we just used a negative symbol. Sometimes you'll just see it like this. That's fine if it has a circle with a negative symbol in it. I didn't draw them like that, but that's fine if you want to. Okay. Now let's go back and review real quick. These are our 3 subatomic particles. Okay, sub means a part of, so subatomic, so 3 parts of the atom, proton, neutron, electron. Now there are a little bit smaller parts called quarks, but in the 8th grade we don't really go into those. You'll learn more about quarks in chemistry. Okay. All right, so let's talk about the 2 parts of an atom, or the 2 locations where these particles are at. We talked about the nucleus. Okay, it's the center of our atom, right here. Okay, it's where our protons and our neutrons are, and that's where most of the mass of our atom is. Again, if you recall what we said, our protons and our neutrons are about 1 atomic mass unit apiece. Okay, and our electrons are teeny, teeny, tiny compared to that. So if our bigger particles are all together in the center, then this is where most of our mass is going to be. Okay, so let's go ahead and label that this entire structure right here is our nucleus. Okay, and as you can see, I just drew a scale that they're approximately equal. Okay, protons or neutrons are almost equal with that 1 atomic mass unit. So that's why most of our mass is in the nucleus. Okay, then we have our electron cloud. Our current model shows that our electrons are traveling in specific energy levels around the nucleus. Again, they're not nice, neat circles. We kind of have to draw them a little bit like that so that we can see them and make a good model for us to use, but that is a limitation of the model that we draw. It's not exactly like the real atom. Okay. And then, like I was talking about earlier, our electrons have different amounts of energies based on where they are in the electron cloud. Okay, the closest they are to the nucleus, the lower the energy the level they have as they move away from the nucleus or they go into a higher orbital, they have higher amounts of energy. Okay, so all of these rings represent the electron cloud. Okay, and then the last thing for our notes for today is electromagnetic force. Okay, this is how our atom stays together. If you will notice, in our nucleus, we have protons and neutrons together. Remember, protons are positive and neutrons have no charge. So that means the overall charge of our nucleus would be positive. Okay, and then again in our electron cloud, we only have these negative electrons. So then our electron cloud's charge would be negative. So if we have a positive nucleus and then a negative electron cloud orbiting it, okay, they, just like magnets, you've used magnets before, the opposite ends of the magnets attract each other. Okay, the south pole and the north pole of the magnet attract each other. Same thing here, because we have a positive nucleus, it is attracted to the negative electron cloud, and that's what keeps everything together. Okay, so that's what our electromagnetic force is. Okay, how electrons stay in orbit. Okay, make sure you bring these notes to class when they are due.